Hi all, welcome to my channel. Today we are going to discuss about the data structures. So I am going to explain data structures in this video. So what is mean by data structure definition? Data structures are systematically way of organizing, processing, storing and retrieving data efficiently. So in order to organize, process, storing and retrieve the data efficiently, we are using data structures. So remember, there are two types of data structures. First one is the linear data structure. Second one is the non-linear data structure. In linear data structure, the data is entered in sequential manner, means one after another. In non-linear data structure, the data can be random. So there are two terms, linear and non-linear. Both are quite opposite. Now you can see here array, stack, queue, linked list comes under linear data structure. Trees, graphs, tables comes under non-linear data structure. Now let us discuss one by one. What is array? Array is a collection of elements with similar data type. Collection of elements with similar data type is called as a array. There are two types of arrays. First one is the one dimensional array. Second one is the two dimensional array or multi-dimensional array. In one dimensional array, remember index always starts with a 0. So this two dimensional array is used for the matrix addition, matrix, most of the matrix applications we are using this two dimensional array. Now let us discuss about the stack. Stack is a linear data structure which follows the last in first out. So here we can say LIFO is nothing but last in first out. So there are two operations can be performed by stack. First one is the push, second one is the pop. Push nothing but insertion, pop nothing but deletion. So if at all you want to insert the elements, you can use push operation. If you want to remove the elements from the stack, we can use pop. Here we can say push and pop are operations of stack. You can see the example push of 1, push of 2, push of 3. When I say push of 1, I insert the value into the stack 1. Push of 2, I can insert one more value. Push of 3, I can insert one more value. So the final answer is 1, 2, 3. So pop nothing but removing the elements from the stack. So this is a stack. I want to remove the elements from the stack. So now I can remove only 3 first because it follows the last in first out. You can observe here I entered 3 last. That's why 3 removed first, 3 deleted first, then 2 deleted, so then 1 deleted. So this is called as what we have stack. Stack follows the last in first out. Again there are two terms. First one is called as stack underflow. Second one is called as a stack overflow. What is mean by stack underflow? When the stack is empty, we can say stack is underflow. When the stack is overflow, if it is full, then we can say stack is overflow. Underflow means empty, overflow means full. So these two are important conditions you must remember while write the exam. Top is equal to minus 1 is called as underflow. Top equal to max minus 1 is called as a overflow. So again you can observe the applications of stacks. We'll use the stack in recursion. We'll use stack in expression evaluation, parenthesis matching, memory management, recursing data, tree traversal problems. We'll use this stack. So overall the important points in stack is stack follows last in first out. There are two operations, push and pop. Push means insertion, pop means deletion. Stack underflow, stack overflow. Stack is underflow when the stack is empty. Stack is overflow when the stack is full. The condition is top equal to minus 1, top equal to max minus 1 for stack overflow. So these all are applications like recursion, expression evaluation, parenthesis matching, and so on. So this is about the stack. Now we will entering into the queue. So what is mean by queue? Queue is a linear data structure which follows the FIFO. So in the earlier we discussed about the stack which follows the last in first out. Now we are going to see about the queue. Queue follows the first in first out. So remember there are two operations for queue. First one is the NQ, second one is the DQ. NQ means inserting the elements into the queue. DQ means delete the elements from the queue. Again there are two terms. First one is called as front, second one is called as a rear. These two terms are belongs to the queue. So how can we insert the values into the queue? You can see 10. I inserted first with empty queue. Then I can insert 20, 30, 40, 50. You see, first I inserted 10, then 20, 30, 40, 50. So this is the queue structure. Who comes the first, they will join. So next, deletion. Removing the elements from the queue. Out of 10, 20, 30, 40, 50. First I can remove 10. Then I can remove 20. Then I can remove 30. Then I can remove 40. Then I can remove 50. So this is called as NQ. This is called as DQ. Now what is meant by queue empty? When the queue is empty, we can say queue is also called as a underflow. So what is meant by queue overflow? When the queue is full. So if front equal to rear, we can say queue is empty. If rear is equal to size minus 1, we can say queue is overflow. So what are the applications of queues? The applications of queues are CPU scheduling, then recognition of palindrome, BFS, breadth first search, as well as in real life call center systems we will use this queue. So what is the short form of this nodes of this queue? Queue follows the first in first out. There are two operations, NQ and DQ. So there are two things again, front and rear. Front means beginning, rear means ending. Now how to insert the values? As per the order. How to delete the values? As per the order. So queue empty means underflow, queue overflow means full. So if front equal to rear and rear equal to size minus 1. The applications are CPU scheduling, recognition of palindrome and BFS as well as call center systems. So this is about the queue. Remember one of the most important point, stack and queue implemented using arrays and linked list. So we discussed the previous stack. Now we are discussing queue. These both can be implemented by using arrays and linked list. So next concept is linked list. What is mean by linked list? Linked list is ordered collection of elements which are connected by pointers. Remember, linked list, the elements are connected through pointers. So there are three types of linked list: single linked list, double linked list, circular linked list. Single linked list, double, circular. What is mean by single linked list? Only there are two nodes. What is mean by double linked list? Only there are three nodes. What is circular linked list? First node is connected with the last node. You can see single linked list means information field, next field. It stores the data. It stores the address of next field. Double linked list have previous data next. Circular linked list, first node is connected with the last node. So this is called as single, double, circular. Now you can see how we can create the structure for single. Now you see information field, next field. So here int data. Data means this information field. Struct node star next. So this is the next node because of the address. It stores the address of next node. So double linked list have three values: data, previous, next. You see here int data. So this is data. Previous struct node star previous, struct node star next. These two are pointers. That's why we have used struct node star previous star next. So when the struct node is same, this is called as a self-referential structure. The name of the structure is same. Within the structure, one more structure with same name with pointer. So this is called as a double linked list. So what is circular linked list? You see struct node into data, struct node star next star head. So this is called as what we have the creation of single, double and circular linked list. Now I insert the values into the single linked list as well as double as well as a circular. So there are 3 elements, 1, 2, 3, 4 elements in single linked list. I inserted 1, 2, 3, 4. One element is connected with another. This is called as a single linked list. You can see the address of 1 is 100, the address of 2 is 200, the address of 3 is 300, the address of 4 is 400. Then this 200 is stored at here, this 300 is stored at here, this 400 is stored at here, because we are talking about the single linked list. Single linked list stores the address of next node. It stores the address of next node. It stores the address of next node. It stores the address of next node. So here this 100 store here. So this is called as a single linked list. Now what about double linked list? You can see double linked list always have 3 nodes. So first this you see 10, 200, 100, 20, 300, 200, 30, null. So there are 3 elements I stored, 10, 20, 30. The address of 10 is 100, the address of 20 is 200, the address of 30 is 300. Now the first node itself it is a null node, the last node itself it is a null. Now this 200 how will come? Because of it stores the address of next node of this one. How this 100 will come? It stores the address of previous node. So similarly this one also. Now you can see it is for circular linked list. The address of 1 is 10, that is going to store in last node. So first node is connected with last node. This is called as what we have the linked list insertion the values. Now you can see how to perform the operations on single linked list. So linked list we are going to perform how many operations are there. Now you can observe on the screen we are going to perform the operations are. So first one is the creation, second one is the insertion, third one is the deletion, fourth one is the traversal. Means in single linked list, double linked list, circular I can perform 4 operations. Creation means it is going to create the linked list. Insertion means I can insert the values into the single linked list. Deletion means I can delete the values from the linked list. Traversal means it display the elements. Insertion, we are going to have 3 different operations. Begin insertion, insertion at beginning, insertion at position, insertion at ending. Deletion means deletion at beginning, deletion at position, deletion at end. Means you can give the position, depends upon that one, it is going to insert. When you say deletion of the position, it is going to delete. So begin, end. So if at all you want to insert the begin, you can use insert begin position. If at all you want to insert the end position, you can use insertion end. So the fourth one is the traversal. What is mean by traversal? Traversal is used to visit the node or display the node. So very important point. Single linked list uses one way, double linked list uses two-way communication. So this point you must remember, you make a note down. So these all are about the linear data structures. Now we are going to discuss about the non-linear data structures. So in the non-linear data structure, first data structure is tree. What is mean by tree? Tree organizes the data in hierarchical form. Tree organizes the data in hierarchical form. So let us say this is a tree. It organizes the data in hierarchical form. So this is called as a root node. These are called as a leaf nodes. So what is the height of the tree? Number of the nodes from root to leaf, one node. So here root to leaf, one node is there. That's why the answer is 1. So types of trees. There are 4 types of trees we have. Binary tree, binary search tree, AVL tree, red black tree. What is mean by binary tree? It should have at most 2 children. What is mean by binary search tree? Left node contain less than root, right node contain greater than root. So when you see the tree, left node must be less than root, right node must be greater than root. Next one is the AVL tree. AVL tree also called as self-balancing tree. The balance factor could not be exceed 0, 1, minus 1. Means when you find the balance factor, it must contain either 0 or 1 or minus 1. Now this is about the red black tree. What is mean by red black tree? Root is a black, no 2 consecutive or red nodes. Okay, so ikkada when you see red black, red is root node is a black node always, no 2 consecutive node or red nodes. Now I am giving explain about this binary tree, binary search tree, AVL, red black here. What is mean by binary tree? It should have at most 2 children. So every node should have at most 2 children. I can say this is a binary tree because this 5 is having 2 children. Okay, so they are saying at most 2 children means you may have 0, you may have 1, you may have 2, but not exceed more than 2. So next here, next one is the 4. So 4 is having 1 children. Okay, no problem. So this is called as binary tree. What about this one? We cannot say this is binary tree because this node is having 3 nodes. So this root node is having 3 nodes. We can say this is tree but not binary tree. What is mean by binary search tree? Root node is having always left side value is always less than root, right side value always greater than root. You can see the value of 8 is less than 10. Yes, okay. The value of 12 is greater than 10. So this is called as binary search tree. Next one, AVL tree. What is mean by AVL tree? We are going to have balance factor. What is mean by balance factor? Left node minus right node. Here the left node is 1. Here the right node is 1. 1 minus 1, 0. Here there are no more elements. That's why 0, 0. So always these balance factor must be only 0 or 1 or minus 1. So next one is the red black tree. What is in the red black tree? Always root node is a red black. Always root node is black. No 2 consecutive are red nodes. You can see here the root node is 9, which is with a color black. So this is about the trees. Now you can observe complete binary tree is there, full binary tree is there. What is mean by full binary tree? If it fills from root to leaf node, if it fills, this is called as a full binary tree. If it fills only the left side but not this is called as complete binary tree. Full means all nodes will be filled. Here complete binary tree means it starts from the left side. So next one, left skewed tree. So if you get the tree like this is called as left skewed. If you get right side, that is called as a right skewed tree. Next one, graph. What is meant by graph? A graph is a set of vertices and edges. G is equal to V comma E. How to define a graph? A graph is a set of vertices and edges. So now you can see this is a graph. 10, 11, 12 are called as vertices. 10 to 1, 10 to 12, 10 to 11, 10 to 11, 10 to 12 are called as a edges. Again, different types of graphs. First one is a directed graph, undirected graph, weighted graph, cyclic, acyclic graph. What is mean by directed graph? When the directions are there, you can observe arrow marks. This is called as a directed graph. When you observe no directions, we can say undirected graph. Weighted graph, the graph with some numbering, this is called as weighted graph. The graph with some numbering, this is called as a weighted graph. Next one is the cyclic graph. What is in the cyclic graph? You can observe the arrow marks. I can start from here, I can go to B, I can go to D, I can go to C, I can go to A. So when you start from A, if you reach again same position, this is called as cyclic graph. Acyclic graph, arrow marks are there, but it does not provide the loop. So when I start from here, I can start A, but I can stay here only because of the arrow mark indicates upwards. So this is called as acyclic graph. Next one, tree traversal techniques. There are two types of tree traversal techniques. First one is the BFS, breadth first search. Second one is the DFS, depth first search. So when you start from A, BFS means which follows the queue, DFS means follows the stack. So it starts from here. When you follows B, breadth first search. So A, it will execute B, C. Yes, B, C. After completion of B, you have again two more nodes, D and E. Yes, D and E. So similarly, E, F, H. But if you see stack, what is going to be happen? When you start from A, you can go to either this direction or this direction. Yes, I can go to this direction. A, B, D, A, B, D, I come back E. A, B, D, E. So then you go again C, F, G. So this is all about the data structures. Thank you for watching this video. Please subscribe my channel. If you have any doubts, you can ask me.